Assistant Director in AICT. So today the project guidance webinar for undergraduates and postgraduates is an interesting topic. It's called Neoteric Frontiers in Cloud, Edge, and Quantum Computing. But today, since the Honorable Chairman has some work, so he'll be addressing uh, the the group first, and then after that we'll take up the webinar. Sir, over to you, sir.
Yeah, thank you, Dr. John. I'm indeed very pleased to welcome our distinguished guest, Dr. Rajkumar Bhaiya, Redmond Barry Distinguished Professor. He is a Director of Cloud Computing Center of University of Melbourne, a known academician, and our students who are going to today attend this particular session would get totally enlightened and would be too happy to know about nuances in the entire technology that is emerging. Dr. Datta, who has initiated this dialogue, I'm very thankful to him as well, and all the faculty and students who have joined this particular 1 hour plus seminar where you will have interaction with one of the finest persons, Dr. Rajkumar Bhaiya, on Neoteric Frontiers in Cloud, Edge, and Quantum Computing. My memory goes back, sir, to 1980 when I joined Indian Institute of Science, Bangalore for my master's and then subsequently for PhD. We all knew that time we started off with small computers, which we called PCs, then PCXT, PC80, then came Pentium. Then there were also some mini computers in some computer labs, a mainframe computer, maybe from IBM or someone. And then we were all struggling to get slot to work on them because there used to be a huge rush of users. And also today we work on the terminal. We used to have data punch cards. That is the history from 80s onwards, where we all started working on those. Today we have supercomputers, mainframe computers, distributed computing. We also talk about cloud computing and also quantum computing, edge. I think things have been continuously changing. But what really changed is the invention of internet, World Wide Web. So by being anywhere with a small device in your hand, you can get services that are available to the best of the institutions on a mainframe or a supercomputer. I think that is the spirit of what we say democratization of computing power that has happened. I think Dr. Rajkumar will certainly talk about all of this and how we are going to go ahead with that. But more importantly, whether it is AI, whether it is IoT, big data, data analytics, blockchain, all of this requires huge processing time and also memory. And the cloud is the best possible available resource right now. But tomorrow we will have quantum computing also coming in. And these applications can be developed by students who are in the remotest possible areas. You don't have to be in an IIT or an NIT or a best institution in Australia or US, but a college student in a remote area also can have access and can develop many things for education, for healthcare, for agriculture, for finance, in all these sectors. And that is what was visible during the last 2 years of pandemic when a huge number of startups came in from India and some of them became what we call unicorns. The whole world's economy was going down, but at that certain stage when even India went down, no doubt about it, but still it picked the threads up and then huge number of startups came in all these domains, whether it is edutech. We have a platform called National Educational Alliance for Technology, where AI-based teaching learning is possible. Students, today's understanding in a particular subject is assessed, and based on that, a journey for a student is crafted, and a student will have an individualized experience of learning. I think all of this is possible because of cloud, because of the distance computing and all of that. Healthcare, India showed the way that the Arogya Setu app, which has been developed, as soon as you go and get the vaccination done, first dose, then the second dose, within fraction of not even minute, you will get your certificate in your mobile phone. I think what a fantastic application that is developed. Nowhere in the world such phenomenal thing is achieved. 200 crore plus vaccinations. I think there is a talent that exists in India. In some places, unfortunately, we do not have excellent quality faculty. And therefore, whether it is our Swayam platform, where our indigenous MOOC is provided through the faculty of IITs, IISc, and best possible faculty. So actually, education at the doorstep is what I'm talking about, or anywhere learning, anytime learning, from any device learning, from any best faculty learning. I think all of this is absolutely superb that we are able to do it. And in terms of agriculture, providing opportunity for our farmers to not only sell their products, to get their fertilizers, insecticides on time, delivery of that using robotics or drones technology, which all require same thing, computing, computing, computing. And therefore, and finally, of course, finance, your whole economy runs on that, and therefore, you name it, and this subject is going to be important, and therefore, Neotic Frontiers in Cloud is going to be a very exciting talk by Dr. Rajkumar Bhuiya. I again welcome him and all the participants who have come, and they will certainly enjoy, learn, and make use of this knowledge for betterment of the human beings and society at large. Thank you very much. Namaskar.
Thank you so much, Chairman, sir. Indeed, we have come a long way from the mainframe to supercomputers, as you said, sir. Your thoughts, words, and wisdom have been very thought-provoking and enlightening. Thank you again, sir. Now, we'll start the webinar. So I will chart out how we'll go about it. So as we said, the topic for the day is Neoteric Frontiers in Cloud, Edge, and Quantum Computing. The welcome address will be given by our director, sir, Dr. Amit Datta. Then we'll have the resource person, Dr. Rajkumar Bhuiya. He is a Redmond Berry Distinguished Professor, Director, Cloud Computing and Distributed Systems, Lab, School of Computing and Information Systems, the University of Melbourne, Australia. After that, we'll have Q&A, which will be also addressed and answered by Dr. Rajkumar Bhuiya. And after that, a small vote of thanks from my side. So before we start the webinar, I would like Manali to play out the Saraswati song so that we can officially start the webinar.
Manali, you have to
Unmute.
audio.
या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा.
Thank you so much, Manali. So basically, the topic, as I said, is Neoteric Frontiers in Cloud, Edge, and Quantum Computing. So basically, this is a modern approach to or discovery to cloud, edge, and quantum computing. To me, basically, in India also, with the advent of 5G technology, fiber, optical fiber, and will be cloud computing, I guess, will be all prevalent and accessible. However, the as with my experience, the mission of smart cities has really not picked up. But I'm sure with 5G and 5G and optical fiber, the smart mission activities will pick up, because silos will be a history, and everything will be on the clouds. Then will be in a more better way to finish off the smart city mission. So, without taking much time, I would like to ask Dr. Datta to please welcome and address the gatherings, sir.
Thank you, John. Am I audible?
Yes, yes.
Okay. Warm good morning to all the students, dignitaries, distinguished guests, Honorable Chairman AICT, and my dear students. It's indeed my proud privilege to welcome the August gathering of visionary academic leaders, my dear students, and our faculty members who all are connected from all across the India. So the attendees clock is ticking up now. 500 plus attendees have joined us so far. In an increasingly digital economy, I would say the basic qualification for gathering a job are shifting as more job roles, technological skill. In fact, the research by the McKinsey Global Institute finds that by 2030, the time spent using the advanced technological skill at work will increase by 50% in the United States and 41% in the Europe. So you can calculate and you can assume that how much it will increase in India, because the time spent using even basic digital skill will rise by 69% in the US and 65% in Europe. So this much increase is already been predicted by the research institute. So how can the educational sector make sure that the workforce has the skill to meet the new demands of the future to work? The technology sector is an ongoing cutting edge of this, because when you come out of the college with a computer science degree, you know maybe a few languages, but you have been guaranteed that those languages are going to change and the approach are going to change. So these are something that tech companies are familiar with, and lifelong learning, reskilling, it's something that just a part and parcel of our daily life. So nowadays, our students are also equal partners in the new academic self-paced landscape, which the unprecedented COVID has had brought to us. So in the online learning, of course, now the medium of instruction may be more focused in the regional languages from the AICT also. There are many initiatives of AICT to bridge the gap, to identify the gap, and to make the intervention in the policies for the betterment of the technical institutions and the course curriculum also. So on behalf of AICT, I once again welcome you all for joining us this prestigious webinar where our distinguished guest, Professor Rajkumar Bhuiya, is going to enlighten us. I once again welcome you all. Thank you for joining with us. Over to you, John.
Thank you so much, Dr. Datta, sir, for setting the right tempo. In fact, your experience and as a doctorate in computer science is a great and learning support for all of us. Now, before I call upon resource person Dr. Rajkumar Bhuiya, I would like again Dr. Datta to introduce him, because he has a long introduction and eminent personality. So please, Dr. Datta, sir.
Thank you, John. We are delighted, extremely delighted to welcome Professor Rajkumar Bhuiya, sir. And just for the information of our attendees, the Professor Rajkumar Bhuiya, sir, has its own web page, and it's so many pages, his achievements. So just trying to put it here concise. Even he has given the link to view the concise CV of him. It's a brief introduction I'd like to give him. Professor Rajkumar Bhuiya, sir, is the Radman Berry Distinguished Professor and Director of Cloud the Cloud Computing and Distributed System Laboratories at the University of Melbourne, Australia. He is also serving as the founding CEO of Manjra a spin-off company of the university, commercializing its innovation in cloud computing. He served as a future fellow of the Australian Research Council during 2012 2016. He served as the honorary visiting professor for several elite universities, including Imperial College of London, UK, University of Buckingham, UK, University of Hyderabad, and Tsinghua University, China. He has authored over 850 publications and 7 textbooks, including Master in Cloud Computing, published by the Macro Hill China, China Machine Press, Morgan Kaufman for Indian, Chinese, and international markets, respectively. He also edited several books, including Cloud Computing Principles and Paradigms, being published by the Miller Press USA. He is one of the highly cited author in computer science and software engineering worldwide. I am delighted to share his H index is 155, his G index is 340, 1,25,500 plus citations. It's a humongous citation, I would like to say. A symmetric analysis of cloud computing literature by the German scientists, ranked by Dr. Boya as the world's top cited author and the world's most productive author in the cloud computing. Dr. Boya is recognized as a Web of Science highly cited researcher for 6 consecutive years since 2016, a fellow of IEEE Foreign Fellow of Academician Europea, Scopus Sister for the year 2017, with Excellence in Innovative Research Award by Elsewhere, and Lifetime Achievement Award from 2 Indian universities for his outstanding contribution to cloud computing and distributed system. He has been recognized as the best in the world twice for research field in the computing system in 2019 and software system in 2021, as well as lifetime achiever and superstar of the research in engineering and computer science discipline twice 2019 and 2021 by the Australian Research Review. Recently, he received Research Innovation Award from IEEE Technical Committee on Services Computing and Research Impact Award from IEEE Technical Committee on Cloud Computing. Software technologies for grid and cloud computing developed under Dr. Buya's leadership has gained a rapid acceptance and are in use at several academic institutions and commercial enterprise in 50 plus countries around the world. He acknowledges all research and institutions worldwide for his consideration in building on software system created by his clouds lab and recognizing them through citation and contributing to their further enhancement. Dr. Bhuya has led the establishment and development of the key community activities, including serving as a foundation chair of IEEE Technical Committee on Scalable Computing and 5 IEEE ACM conferences. So these are the contributions of Dr. Bhuya. Dr. Bhuya are recognized through the award of 2019 IEEE Medal for Excellence in Scalable Computing from the IEEE Society, TSCS, Microsoft, Aneka Cloud Computing Technology developed under his leadership has received 2010 Frost and Sullivan New Product Innovation Award. Dr. Bhuya received Mahatma Gandhi Award along with the gold medal for his outstanding and extraordinary achievement in the information technology field and services rendered to promote the greater friendship and Indian international cooperation. He served as the founding editor-in-chief of the IEEE Transaction on Cloud Computing. He is currently serving as a co-editor-in-chief of the Journal of Software Practice and Experience, which was established 50 years back. I once again welcome you, sir. It's a heartfelt welcome from the bottom of my heart. Kindly address the gathering, sir. Once again, welcome from AICT, sir.
So thank you very much for your kind introduction. I, of course, like to offer special thank you, Dr. Amit Datta, for inviting me to be part of this program of educating students in advanced topics. Then how they can use those in creating interesting projects, and then of course the skills that are gained can be very useful for advancing national education mission, national economic mission, then of course helping industry when they join in building real world solutions. I thank your chairman, Professor Anil Sahasrabudhe. So initially, he inspired by telling us the history of computing, how it was there during, something like 50 years ago, to how it progressed now, and potential opportunities. Then the way in which India is rapidly adopting them in solving or addressing challenges. One of them was how during this COVID-19 challenge that the world face, everybody face, including India. So how even vaccination reports or data or certificates, how quickly they are made available, especially you need it if you are especially traveling or visiting. Even the shops here in Australia, they had such constraint. So unless you show them a proof of vaccination, they won't let you in. But now that is recently took away that constraint, but at right time it was very essential. So that was all fantastic in setting the scene. So now let us move on to our proposed topic on new trade frontiers in cloud, edge, and computing. Let me share the screen. Okay. Yeah. So you can see the screen.
Yes, we can.
So do you see just one screen or two?
Two screens, in fact.
Okay. Let me stop. Now I think one.
Now one. Yeah.
Thank you. Yeah, hopefully one of you can keep your video on, so that way I know that it is all going fine, or
Yes.
network is not broken.
Yes.
Thank you very much. Yes. So these advances that we look today, the latest in computing, that brings both computing and communication together. So they are advanced to support various kinds of applications. The two prominent ones that we see in industry very heavily pushed is big data, and other is Internet of Things application. So of course there are many enterprise applications are there. I would like to share the thoughts in this context because these are something when we build such application, we can put in practice, put it in real world. Even common man in villages can benefit from it. So therefore I thought I would focus on this aspect a bit more in terms of application and how they drive the advances. So let me briefly present outline of our discussion for next an hour or so. First, I will introduce very briefly different computing paradigm that emerged, some of which our chairman has already touched on just briefly, but our focus is on cloud and edge and quantum. It is good to know. Then we will take a look at a bit more into cloud computing and the applications today and the trends. So then, because we also want to look into the future trends in this area, so therefore we take a look at some of the application drivers, applications that are driving the new advances. That's the first part. So next we will move on to what we call market-oriented cloud computing, systems and platforms. So in cloud computing environment, you actually subscribe to services and pay for what you consume. Is a subscription model. So market principles plays very important role, how you allocate, how you manage as a service provider. So how you price, how you deliver services, and as a consumer, you can define your requirement, and accordingly system will select suitable capabilities for you to meet your requirements of such as quality of service constraints and requirements. So then we will see how this can be realized by taking a look at one of the technology that developed called Aneka. Is a cloud application platform. So earlier our colleague mentioned about we started a company called Manjaro Soft. It is a spin-off company from our laboratory, our University of Melbourne Cloud Computing System Lab, where we are able to take the technology that we created and commercialize successfully. So this is something, of course, is also important for students to gain skills. Earlier, our chairman also mentioned about this entrepreneurship, innovation entrepreneurship push in India too. So hopefully that can inspire some of our attendees or students to think of creating something simpler application that can be made available to everyone at a small affordable price and then make it successful. So with that understanding, we will take a look into a little bit more into Internet of Things. So this Internet of Things means connecting this physical world and digital world. We have digital world and the physical world. So when we interconnect them in a seamless manner, so then we will be able to create a smarter environment. Say, for example, if you interconnect a road network in the city along with this digital network, then from that you will come out with some applications such as smart transport system or smart healthcare. So these are smart environments that you create. That way we can use the resources that we have in the world or in the city or in the country more efficiently. So application can be, if it is villages and all, how to do efficient agriculture, water efficient agriculture. So these all are an extent are possible, can be made possible through Internet of Things. The thing that we can monitor the activity in the physical world, then accordingly take decision so that we can use resources more efficiently. So we will see, we'll discuss few those applications and trends in that context. And to meet in particular requirements of Internet of Things application that needs real-time services. So this is where some of the new computing paradigms that extend cloud computing towards edge of the network. What we call them, some call it as edge computing, others call it as fog computing. So we will discuss more conceptually. Then we will take a look at an example software technology that helps you realize with example. Then we can take a look at healthcare application. So I have an example of healthcare application. So there's a practical environment. So usually the researchers, so when they are conducting research, often they go for model approach called modeling and simulation, whether it's a cloud computing environment or this new edge and fog computing environment. So there are modeling and simulation. So toward that end, we developed appropriate simulators for cloud computing, something called Cloud Sim. So that is used all over the world. And numerous companies are using. Then similarly, we also have a iFog Sim. So the simulator for edge and fog computing, that is developed. So then we will discuss also an effort in putting together drone-based solutions during this COVID pandemic management. So we will discuss with a little bit more detail later. So then, of course, quantum computing. So we hear a lot about quantum computing these days. These quantum computing services are made available to users today through cloud. We may not have a quantum processor on our laptop during next maybe 10, 15 years time, unless the technology changes the way the quantum processors are built. So they will still be accessible through cloud due to various cooling constraints and so on. So these quantum-based systems, capabilities are also made available through cloud. So what do we do about application engineering? So when you are creating application, you build application, then you want to deploy in this large-scale computing or a cloud environment. So if your application component contains, let's say, a quantum code, we should be able to seamlessly deploy that part if necessary. If your application has a code for GPU or TPU or quantum, so depending upon the resource availability, we should be able to dynamically select suitable code and deploy. So in that direction, recently we have developed what we call QFAS, Quantum Function as a Service. Using QFAS environment, when you build your application, so application will have the traditional software models. That may also have some quantum enabled model. So our system is able to dynamically deploy, and this way we can enable seamless integration of classical CPUs, computing environments, and also quantum, everything else in between. So this is becoming a big, trend these days. Especially there are class of applications in security, in even AI. So they may need, some of them need quantum capabilities. So as it is a new trend and there's a big software gap in quantum computing, so we wanted to fulfill that one. So a colleague from IBM mentioned that the software technology for quantum computing today is very much like software technology for our classical computers 50 years ago. So that means, so a lot of advances is necessary to be able to to be able to enable ubiquitous usage. So to overcome the limitation, we have started this quantum computing research and then develop the software, and so it will be made available for public usage soon. So we'll conclude and discuss some future direction afterward that. So this is the plan for our discussion. I actually the program plan today, I see that significant amount of time is allocated for question answer, any possible discussion. So I will be able to take any questions or clarify any of these points, or maybe we discuss openly what are the new things that can be done in India, Indian context itself. Okay, so waves of computing or computing paradigms. I guess this was already mentioned by our chairman, Professor Anil. So that is, we build on in that case. So you can see the computing paradigms. I have actually picked up some broader ones. During 60s, what we call mainframe computers were there. Already it was mentioned how the uses of mainframe computers was, but move forward to something like say 90s. So that time these local networks became prominent and internet started coming up, and then web started appearing. So what we see from 1990 to 2010 or so, there were a lot of advances in LAN connected computing and also World Wide Web, and then also things such as web services to enable service computing model. So that was highly successful. On the other hand, the application that we developed, they were very much tied to a specific server or a OS. So if, for example, on your in enterprise or on our laptop, we have an application running on the system, it is tied to there. And tomorrow, if I buy a new laptop, I possibly have to reinstall everything in another new laptop. But that model is being challenged through the introduction of this notion called virtualization. So you virtualize an environment. On top of the virtualized environment, let your applications or OS or whatever sit, and then you can actually change hardware, or you can move your application from one server to other servers very easily. So that is what is made possible by virtualization, and then so that has led to what we call cloud computing. Actually, the concept like cloud computing, delivering computing as a utility, just like electricity as a utility, or water as a utility, or gas as a utility. So this concept has come to computing. So which means you don't have to buy hardware, software yourself. So you can just rent these capabilities from somewhere in the network, which is what cloud computing is going to possible. Between this cloud computing and then this whole web, there were other things such as grid computing. So which was also similar model, but the grid computing was focused on primarily big scientific application, and this cloud computing has brought this that notion to consumers, large enterprise, business and consumer environment, where anyone can rent required capability from the third party, use it, and you pay for only what you use. You don't worry about paying anything unless you use it. So that's the model cloud computing. We will see more detail as we go along. Then this IoT, Internet of Things. So making sensing activities in the physical world and integrating those with the digital world, so that we can manage environment better. So whether it is a transport environment or a healthcare environment or a home environment or agriculture environment, so manufacturing environment, we can automate that process. By doing so, we can use the resources more efficiently. So in that context, this IoT based application so far were mostly cloud centric, but with massive emergence of IoT deployment globally by 2030, billions of those, which means this model of pushing the data to cloud is not going to be suitable. Therefore, we need to look into other one, is what we call edge computing, that becomes so popular, getting popular. Then quantum, of course, has been, people are working a lot on developing quantum hardware, driven by all this quantum mechanics concept and so on. So we see this quantum is another one, and now this is already available to selected users through cloud. So these are the different computing paradigms that how they emerge. So hopefully by 2030, so all this quantum, cloud, and edge are seamlessly integrated, and then they'll be used, and then we all use it as if we don't even know their existence. So that will be a success of the field. So all these advances that we see, what is the driver? Usually they are driven by applications from science, from military, government, the big scientific and engineering and military applications were the drivers for advances in computing and communication technology. In initial 40 years or so. So more recently, during last 10 years, that has shifted towards big population. What can we do to bring these innovations and benefits to the large consumers, and who can access it from wherever they are, and what are those applications? So this is really a big focus. The cloud is very much heavily towards enabling solutions that benefit the large population, not only just corporates, but also big population. Okay, so that is the driver for key paradigms and drivers. So now looking into what this cloud is. Cloud essentially offers subscription-oriented services. Subscription-oriented. So just like when you build a house in Delhi, so you don't really dig your own, water well, for example, simply build, then you subscribe to a water supply network offered by some kind of, Delhi Water Supply Board. Similarly, when you build a house, you don't really set up your own big power production environment. Instead, you subscribe to a electricity service provider board. So if it is Karnataka, they say Karnataka Electricity Board, KEB. If it is Delhi, there might be one like that. You subscribe and use it and pay for what you consume. When you subscribe, they put a meter. The meter measures how much you are consuming. Accordingly, they charge you monthly bill. Same thing with water. Similarly, the concept has come to computing, which is called utility computing. Computing is a utility made possible by cloud computing. Cloud is the one which actually made this real and possible. So that means users can subscribe, use it, and pay for what they consume. Here is the high level view of what cloud might look like. So we have various kinds of access devices. Then users subscribe, and there will be a service provider such as cloud service provider, which are called as the public cloud service providers. You subscribe. After subscribing, depending on requirement, you can rent physical infrastructure such as servers, or you can rent a platform that helps you to develop application deploy, or you can deploy the last one called software as a service, which is applications. So if you are an end user, you don't worry about all this. You just simply subscribe to application services, use it, and pay for it to consume. And these in the SaaS environment, the varieties of applications are already created and made available. So when you subscribe, it may look like you subscribe to one service provider. Actually, that service provider uses capability from multiple other providers and deliver you required capability. So that means, so it is not just one provider doing everything for you. So this provider might be using service from other provider, service from third provider, like this, put them together, and what they deliver to you is a composite service. So you no need to know about all of these low details internally, but this is how the services are architected. And when you see some of the applications, that's how they're built. Now, what are the applications that are, right now we all are using benefit from cloud? Many. I'll show you many of those you are using. The traditional business applications such as CRM, customer relationship management, then accounting softwares, then resource planning, enterprise resource planning software systems, e-commerce. So all these are already hosted in the cloud, and we are using it every day without our explicit knowledge. They are delivered to us. And other things such as Twitter. This Twitter is a micro messaging service. Where is it running? So this is running on a cloud. The application like this can have a large number of users that vary with time. Sometime during peak time, maybe 10,000 users are using. Other time, maybe only 20 users are using. So this micro messaging service. So if you build like this, your own office, your own organization, you will build it for a peak requirement. But most of the time, the resources are unused. So that model, that is too expensive to build. Therefore, you can move to cloud where you can rent what you need, how long you need it. So depending upon your requirement. So this Twitter application is running on a cloud. Very simple. If you go to twitter.com/Bhuya, that is my Twitter site, At the bottom, it will start showing you the browser. Where are you visiting to fetch the content? Most of the time, it is visiting, for example, s3.aws.com, storage service offered by AWS. Like that, other cloud service called this Dropbox. Dropbox is essentially a cloud storage service. See, in your laptop, so you have a storage, but you want to keep a backup somewhere else, or you want to share with others certain files, or edit together. So this Dropbox can be used. Dropbox is a cloud storage service. It's like a seamless file system. So they implemented in such a way that you can have a folder with one small Dropbox program running on your computer system. It gives you a folder. That folder, the moment you have that folder, the virtual folder, virtual directory or folder, whatever you put there, it looks as if it's a local file system, but actually it's backed up remotely, and it is shared, synced, so that you can collaborative development can be done. Like this, even the Facebook is a cloud-based application. Gmail is now cloud-based email server system. Then this Zoom or a video conferencing software such as what we are using today, WebEx. So these are actually cloud-based application. You see, I just have some simple client, and then I give an ID and I just log in. Like this, hundreds of participants, thousands actually. We are the big 500 plus participants we have. They all joined seamlessly, so and highly scalable. And of course, for our request, some of you, when it created an environment, it has created some of these instances in the application, maybe in Delhi or in Bangalore, so that you all have best of the same. For me, maybe in Melbourne, like this globally. So seamless multi-cloud distributed environment is used to support this. So these are some of the applications. Then just briefly to show you some e-commerce oriented associated application which are hosted in cloud. You can see, especially I want to show you how many requests are processed per minute. In 60 seconds, what happens on some of these popular applications, popular applications that are hosted in cloud. If we see, for example, Facebook, this is 2021, 2022. So this is the most latest figure. You see, at any point, within a minute, you will see more than 1.4 million users are accessing or scrolling this content. Now you think of a computing environment that can support so many users at the same time. You know that if you build it an application running on one server, it can easily comfortably support maybe 100 users at any point. But if you have got millions, that application cannot be written for one server. It has to be across servers and also geo-distributed. We will come to that point as we go along. But what I want to highlight is the huge success. So in Twitter message, lots of people are using Twitter, this Twitter for micro messaging services. Not just common people, even the leaders of the country. All these leaders such as prime ministers and presidents. Some of them are literally running the show through, sharing their plan or decisions or policies immediately through like this micro messaging platform. So this is a big trend, and these huge number of users, you can see thousands of hundreds of thousands of messages are at any point. So this is a big usage of cloud. You can see cloud is here and it's successful. So that is a success. That's fantastic. So now looking more into architecture of cloud application engineering. Before that, I want to highlight that there are many more new trends. Recently, we have what is called this microservices. So here, so this is microservices, moving from a virtual machine to microservices. So this way we can do better software engineering. Then this concept of Internet of Things, which we discussed briefly, the network. Not only virtualized compute, but also virtualized networks. That is called software-defined networks. So these days, the software-defined has become really a fashion or a prominent. People talk about software-defined building. You define a building through software. That means you plan the activities, how the building, within the building, how the lighting system, heating system, cooling system, efficient management. So you define in your software, the rest will happen in the field building. So it's called software-defined building. So this is getting popular. Then this blockchain, we hear a lot, blockchain, mostly in the context of digital currency. from printed notes to digital notes, digital currency blockchain. So this same blockchain can also be used for creating trustable services. If I'm consuming services over the network, can I trust them? Can I trust the result I'm getting? In a healthcare domain, I capture the data and then can I trust it? So you can do that by integrating blockchain into your computing environment. So I will discuss about that also. Then of course AI getting so much popular. I see even in India, national AI, initiatives, national supercomputing initiative. We also hear that the government of India want to tax people for earning money in bitcoins. So that means it's also becoming serious. So then this COVID-19 is another big trend, may not be trend, but the big crisis that world faced. But crisis has to be handled. So this is where cloud played a very important role. Particularly, I want to highlight some of those innovations that happened during last 2 years. Then we all know the impact this COVID-19 had on life of people, livelihood of people in the business and the economy, education. So there are some good things that came out of it. Is that the cloud computing or some of the computer technology played very prominent role, and then they become more ubiquitous as a result. So during this last 2.5 years, with the lockdown happening, where people working from home, lockdown is still there in some of the countries like China. So there's zero COVID policy. So you can't just fly there and start working. You have to quarantine still. So whereas in other countries they are not worried so much. So they vaccinated or yes, business as usual. What can we do? We have to tolerate. So this essentially the use of cloud computing, hosting remote business services has led to the use of usage of cloud computing for those applications almost doubled. If you look at 2019 to 2021, during last huge usage, more and more, and then suddenly this Zoom or WebEx, all this became very popular, and everyone has it. So this AI, AI techniques used in different applications such as healthcare, robotics, then the future, what we call driverless cars or smart transport system. So these are the where many of these AI techniques are also used, which means they are actually powered through cloud. So yeah, all these AI applications need massive amount of computing in terms of model training, in terms of predicting trends by looking into the past data and model. So that actually enabled through cloud computing. Although actually some of you know that even 25 years ago, 30 years ago, AI was very popular, but it didn't really reach benefits of applications benefiting the application didn't really come up, mainly because the necessary environment was not there. Computing environment was not able to support suitably. But now with this cloud, it's all becoming real. So that is about cloud computing, the trends, and the cloud computing applications today. So now, how does this trend impact, and what kind of new applications that we can enable? So that is the focus will shift. So for that, from that context, we move to market-oriented cloud architecture. So here, so this is a bit more detailed view of cloud environment. So in the cloud environment, so let's say a physical data center, so has many physical servers, and here you see physical server. These are servers. They are interconnected through network, and then they are virtualized through software-defined networks. So here we have got software-defined network that virtualize the network. Then the compute not only virtualized through virtual machine, but through these containers. Now go up. So here are the top application users. So these are different application users. They submit the requirement. Say if it's a healthcare application, you might say, here is my healthcare data. I want it to be processed and results given within 5 minutes, for which I'm willing to pay 10 rupees. You define the requirement. So this is where you have service pricing too. So these service providers charge the prices too. So when the requirements come in, first see whether you can admit the request and meet the QoS expectation. So admission control system will see how much resource I got, what is the expectation of this person, and how can I deliver. So accordingly comes with appropriate admission control, then allocate the resource and provide service to the end users. So now for your request, what is created is a virtual machine. What you are renting in cloud is a virtual machine. Cloud service provider don't rent you a physical server. What they rent you is a virtual machine. So given your specification, accordingly to meet the specification, virtual machine is created. Say virtual machine with 2 gigahertz processing capability and then 2 GB of memory or 20 GB of secondary storage. You define if it is infrastructure provider or application levels quality survey requirement. So the virtual machine is created. So this virtual machine is mapped to a physical machine depending upon the requirement and the where user is coming from. So when this event was started, we started with few users, then drastically keep moving towards 500 and more. So as number of users is increasing, the system is dynamically figure out, oh, we got a lot of requests coming from this cluster, this group of region, this region. Accordingly, it will create a virtual machine and place that virtual machine on a physical machine close to set of users. So this way we can get the best response time. That is called VM to PM mapping. So you need to think about that. So and also it depends on application type as well. So then with the time, the demand on the service can increase. When the demand on the service increase, number of users are increasing. At that time, whatever resource that are leased to support services are unable to meet the quality of requirement. So therefore, what we can do, we can dynamically add extra resources to the cloud environment, to your application environment, then seamlessly deliver to end users. So this addition, expansion can be within one cloud environment or across multiple cloud environments which are geographically distributed. So here you can see, so some of them are also added in another location. So geographically distributed environment means like in cloud environment in India. So you are running initially maybe Delhi, prominent, slowly number of users are increasing more in Karnataka. At that time you can migrate some of these application services towards servers located near Bengaluru or in Bangalore. So this way you can make them affordable, accessible with the quality of service to end users. With time, when number of time user decrease, then you shrink it. So this is called elastic computing. So you can expand or shrink as needed. So this elasticity is a very important concept, in computing. So by doing this elastic approach in resource management, allocation, and delivering of services, what are the benefits we gain? The first benefit is cost efficiency. So you only pay for what you consume. So that way. Then the second is resource efficiency. The resources are not simply kept it on when it is not necessary. Third is energy efficiency. These cloud data centers are consuming enormous amount of energy. A typical one cloud data center is consuming energy equivalent of a big city, like city of San Francisco and so on. Huge energy consumption. Not only that, the cloud data centers worldwide, the total energy consumed by them is more than entire India. Entire India, how much energy electric power is consumed? More than that, more than 600 trillion watt hours per year is consumed by cloud data centers. So it's a big problem. So having this sufficient elastic approach to resource allocation, we can minimize the energy consumption also. So which is important too, because if it is too much of energy consumption, electric energy consumption, it also means carbon footprint into the environment. So they are powered by often by brown energy, which is created possibly through coal burning and so on. So that is all conceptual. Now let us see. Actually, now to enable this, we also need to have applications that can scale seamlessly. If application is just rigidly built for one server, it can't benefit from cloud computing. How can we engineer an application that can scale? And how can we engineer a system that can deploy these complication tasks across multiple servers? So from that perspective, let us take a look at a cloud application platform that so we have developed. So we will take question answers at the end. So okay. So that brings to our Aneka cloud application platform. See, this Aneka is a software system that we developed that enables you to create such applications, then deploy them. So to support that, we have two type of component. The first one is this software development kit. The second one is runtime machinery. So this software development kit supports various APIs and tools that you can use to build application, such as thread model programming. So those of you who know Java programming, in Java there is a concept called thread programming in Java, Java threads. So using Java threads, when you build your application, what can you do? When you run that application with multiple threads that can run in concurrently, if you run it on a multi-core server, it can harness the power of all the cores within that server. What if you have, if in cloud environment you have multiple servers, you won't be able to scale that application across multiple servers. But you can do that if you build using Aneka's this thread model programming. Like that, we also have task model programming, which enables single program multiple data model. And there is something called MapReduce program model. So this is also very popular, and for example, many Google applications are created using MapReduce. So in Aneka, we have all of these supported in single SDK. And once you build those, you can deploy either on a private cloud, that is a cloud that is established within an enterprise. It's also called as hybrid, in enterprise cloud, or you can deploy on all these cloud resources that you rent from different providers like Microsoft, Amazon, Google, or whoever. Okay, seamless deployment. So these features of Aneka makes it very unique. That is why we say this is a world first platform to be able to support multiple of these in a single technology or SDK. When you go deep inside this Aneka, what is there? So inside this Aneka, we have a what we call Aneka container service. So this Aneka container service has got various key modules that are common, and these can be used to create different models of programming, thread, task, MapReduce, and we build that way. Then once you build, so you can deploy those applications either on private cloud or public or multi-cloud environment in a seamless manner. So now, so here, tomorrow you have a new idea. So you heard about this. Tomorrow you come out with a new idea for how to create IoT applications rapidly. For that, you might come out with some kind of library or some kind of model of programming expression. So you can easily implement that idea within Aneka by extending the core foundation services that Aneka offers. Okay, so this Aneka technology will go more deeper. If you want to see the historical progression, the cloud computing was gaining slowly started appearing in 2010. So by that time, we also created a technology called Aneka 1.0, catering to the needs of bioinformatics engineering running on cloud. So over a time during last 10, 12 years, we have constantly enhanced this technology to meet the requirements of new class of applications. The latest being move Aneka 5.0, supporting these applications from AI, deep learning, IoT. Well, in between every few years, we release new versions of the software to support them. Now this cloud computing has become successful. Numerous vendors like Microsoft, Google, Amazon, many small, they all created various cloud data center around the world. So to be able to harness them, we need multi-cloud platform. So this Aneka has been extended to support those multi-cloud. So you might have a private cloud built using, say, OpenStack. Or you have a public cloud such as Microsoft One or Amazon or VMware you want to access. You can use them seamlessly. To support that, Aneka has what we call Aneka plugins. So these Aneka plugins for different environment. So for Azure, for Amazon, for Windows, for Gen Server. So these plugins, hide the differences from different providers. As you know, each provider has their own access interface, their own APIs. So if you are building applications for each and every one, it is not feasible at all. So instead, if you use technology like Aneka, that takes care of deployment of applications seamlessly and delivers services to you. This Anika technology is used by many users worldwide. Let me briefly present some of those. So here I picked up a few different countries so that we can appreciate the global nature of the technology and the usage in different countries. So from China, China Railways Corporation, then India, ISRO, Indian Space Organization, they use it for satellite image processing. So similarly, Washington State University, they use it for medical data analytics, such as privacy aware deployment of medical data on cloud. So then IIT Delhi, for example, using it for such as deep learning applications deployment on cloud. So this AI application. So also this COVID-19 open resource data challenge that was there, and we also participate through our technology. So we will touch on each of these a bit more depth. So this China Railways Corporation, what do they do? They are involved in building high-speed trains for China. Here are different train design scenarios. So this is rendered using software called Maya on all these different scenarios rendered on this 4-core server. So this was taking anywhere between 20 hours to 80 hours, like 1 day to 4 days, depending upon complexity of the design. To minimize the time, so they have set up this private cloud environment with multiple servers interconnected. We have a tool called Design Explorer. So this Design Explorer allows you to compose this application as SPMD, single program multiple data, and deploy. Then process here, and after processing, results come back. And when it was done on this 4-core server, what took 80 hours, the same thing they were accomplished in, for example, 2 hours. So this is a Anika-based cloud. Now you might say, 2 hours is a long wait. You want answer within 10 minutes. How can you do? So the local resource that you created within your enterprise or office or a college or a university, it takes say 2 hours. Suppose by good fortune, say Modi is visiting, Prime Minister Modi is visiting your college or your design center, so he will not be able to wait 2 hours for him to show train design scenario. Oh, here is a scenario 1 for a train from Mumbai to Ahmedabad. Obviously, he will be very curious because he is from Gujarat. Curious, well, what can we do? Maybe we can create some cost efficiency. So what is the design scenario? And you need that scenario analysis 2 hours, can't wait. What can we do? We can, in this Anika system, there is a provision QoS, you can set deadline inside. The deadline parameter is equal to maybe 10 minutes, right? So deadline 10 minutes, give him a copy, let him sip a coffee, meanwhile set a deadline. Then the local resource cannot meet. So therefore we can now rent extra resource from a public cloud. So within an enterprise, so local, then extra resource that you need to meet this need, you can just rent from public cloud. So that is, you have to pay for it. Therefore you can set a budget. So you can set budget is equal to say 50 or 500 rupees, 500 INR, okay, RS. So there's a budget. Given a deadline and budget, now Anika has cost-oriented technique where it is able to look into. So here are the cloud services offered by Microsoft, offered by some of the Indian companies. This is their price for virtual machines. So based on that, given your budget limit, given your deadline, you decide the system automatically on your behalf rent the resource and then transfer the task to those places and process it and bring back within the deadline of 10 minute budget limit of 500 rupees. Suppose it's not feasible, you would say it is not feasible request. Correct? And this is how we operate in our real life. If I am going, say, from Delhi to Bangalore, I can fly, maybe cost you 10,000 rupees, or I can take a Indian train, cost me only 1,000 rupees, but there is a timeliness. The budget limit is the time is there. If I got 24 hours, 80 hours, I can just take a train, go slowly, spend just 1,000 rupees and reach destination. If it is urgency, then I must spend more time, more money to pick up and choose the right mode. But there we do manually. But here in Aneka, you define the requirement. And this is the same model even at ISRO. ISRO satellite image processing, when they have a satellite data and this data came into receiving station where processing is made, the ISRO center in Hyderabad, they built an application to be able to process when there is a emergency. They not only use the Hyderabad center data center, but also the cloud data center environment in Delhi, in Ahmedabad, in Trivandrum seamlessly and do it. So I actually put China's one, but the Indian was also there. Okay, so that is engineering. So now you think of application engineering within Aneka, you can use thread model programming. You are familiar, or a map reduce, or a task. You can compose application using our API or use our tools and build it. So next one is healthcare. So healthcare is these days is a prominent one. So let us briefly look at how this is enabled. So healthcare, nowadays sensors are coming. See, body area sensor networks are, so even the watches are coming with ECG sensor. You just wear a watch, the data collected, and this data that is collected through Bluetooth networking can be sent to a mobile phone. So this app can capture the data, then send it to an application service running on a cloud environment here. So here is the ECG, just SaaS, software as a service, software as a service built on top of Aneka. This is built out of Aneka. So Aneka can now take it to your application task and then deploy on this cloud environment and send back. So why do we need such a technology? Because the number of using this healthcare application can be numerous with time, thousands and thousands of users, and each of these users have a different requirement. Like today, I just monitor my healthcare app, monitor maybe once in a while, and I'm happy to get results in 24 hours. How I'm doing. Somebody in emergency, they need immediately within 5 minutes or 1 minute. So these requests, then accordingly the price can be different. So these are like a market style services also supported in Aneka. So this is we have showcased this a couple of years ago. Now this slowly becoming part of real world. You can see this sensor data we kept connected to this person's hand. Then from there we send it to mobile phone. From a mobile phone send it to in like a cloud environment where processing is done. Processing is done. Then results came back. So here you see this graph, correct? So just by looking at this graph, you can tell a lot of a person health condition. So this is an example of simple building a healthcare app and having some kind of application service in a cloud environment. You can immediately support large number of users, and this is affordable. This sensor that we talk about nowadays, they are just coming. Soon I will see another sensor, oximeter. So it is coming at price of something like 800, 900 rupees. So you can easily use. You keep it at home. Multiple people at home can use it. Data collected, send it to cloud. Okay, looks like everybody happy, healthy. If someone is having some problem, oh, you have this problem, so you better take care and change your diet. What you eat, don't eat too much of chili, maybe change it to something else. So this kind of guidance can be given. So this is a healthcare example. So this is AI. I want to talk about AI. AI is one of the important one. So AI, artificial intelligence, AI techniques like machine learning within the deep learning using neural networks. So this AI application can be used for object detection. There are many applications where this object detection can be put in place in smart transport, in security, in university, in colleges also. So here is IIT Delhi has developed this application. So these cameras are put everywhere these days. Even the student labs here, the camera people put here. There's a camera, multiple places, cameras. So these cameras are there. What are they doing? Cameras are capturing images or videos constantly. So now you don't have to time to go through a video all the time. Instead, dynamically, if there is an event of interest comes up, you'll be triggered. So here these images are coming in, and there is a deep learning program. There is a program called deep.py. So this computing program was running on one server, takes a lot of time. So they built this Aneka-based version, took that deep.py. Using Aneka task model programming, they are able to split, take these images continuously coming in and process them in parallel. This is like a processing, supercomputing. So process in parallel on using, Aneka has multiple workers that can process it. and then bring back results. And then if the local resource not able to meet the requirement, as I said, you can use public cloud as well. This Aneka does similarly for you. And here is the example. This is the input scene. So when it's processed, it is able to classify, detect objects in the image. For example, it says monitor, keyboard, mouse, chair, key, how many people are inside the room, oh, is something missing? All this can be done. So this way you can ensure security of your laboratory environment. You can ensure security of your state network, transport network. You can ensure security of the buildings. So this is an example of deep learning task running on Aneka based cloud. This is my last example of Aneka based application in the context of COVID. So during last 2.5 years, I think now already almost 400,000 research papers are published from different community, from computer science, from medical, from economics, from social networks, social science, politics. What are the policies and all? Lots of papers are published. So you want to find out what is the latest vaccine that is most effective for the today's variant. You can't go through 10,000 research paper to find out what is the answer. So maybe you want to rank them. So going through this is challenge. So there is a bibliography available called Code 19 dataset. COVID open research data dataset. Huge amount of data available. So to support that, we created a machine learning based program. So that machine learning models trained using Aneka. Here is Aneka. So these model training, after that processing, they are done processing parallel or different number of servers, and results presented in timely manner. So here is a simple graph showing you, depending upon number of records in the database, publication database. So if there were just, say, for example, rented one server in a cloud, this was taking like 4 or 5 minutes. Actually one server here, that was taking something like 20 minutes. The same thing you are able to do in 4 server within, say, 4 minutes. Okay, this is 20. So this way you can reduce. But if you put all the data and then refine the analysis, then you need to be able to dynamically provision. So this is the nature of how Aneka is able to support dynamically. So now, so if you want to explore this Aneka yourself, you can visit manjarasoft.com, as I mentioned in the beginning. So Manjarasoft is a spin-off company from our laboratory. Our research is a commercialization. So you can actually download this Aneka latest 5.5th version. Numerous users in India, many students have downloaded, and then they created very interesting application, published papers. And many of them, sometimes they connect with us, and then immediately getting jobs too. So this is done by even the master students, even the undergraduate students. If you search for publication, some paper, Aneka in cloud application, if you put that keyword, you will see lots of paper coming up. So that is the success. And then of course, throughout the country, numerous universities are starting to teach a theory in cloud computing, mastering, the theoretical subject as well. So they use this book, Mastering Cloud Computing and Teaching. And many of these have set up a laboratory. For example, in Delhi, Jawaharlal Nehru University, JNU, and also NIT, National Institute of Technology, Delhi, they have set up an Aneka-based lab and teaching practical experience, not just theory. As you know, in computer programming or software engineering especially, so if you practice, then only you become perfect. They're like art. The art need to be practiced. So if you don't do programming regularly, you can't really, you forget the theory concept that you learned very easily. So to overcome the limitations, many of these you can see from all the way from places like Punjab to see like a Tamil Nadu, and then Maharashtra, from Maharashtra to Meghalaya, both north, south, east, west, full cover, including Bengal also, West Bengal University of Technology, WBT. Now they call Makout. I think Maulana Abdul Kalam, something that University of Technology. Now they changed name. So they are teaching hands-on experience, their laboratory subject as well. So huge number of NITs, which you can see are many of these, many big college universities like Rajiv Gandhi Technical University, then Rajasthan Technical University, Punjab Technical University. So when they introduce in such university, the statewide can benefit. Yeah. So that is Aneka and cloud. So now let us take this concept more towards towards IoT and application engineering. So IoT, we will extend cloud concept more towards edge to enable this IoT. So this IoT, by 2030, more than 500 billion objects become part of internet. Means everything, physical machinery, a light, a house, road, signals, your watch, all become part of internet. So they become part of a network. And then it is expected that the huge economic opportunity, trillions of dollar, that means maybe 80 trillion rupees opportunity per year. So huge opportunity. So this adoption of IoT is rapidly progressing worldwide. All things becoming part of the network. So that presents a huge opportunity. So to create what we call a better healthcare environment and smart city environment, smart agriculture environment. In agriculture environment, using water resources very efficiently depend upon type of tree. Correct? So you can't simply irrigate just randomly all the time. So you can have a moisture sensor. Moisture sensor can monitor, accordingly send you a signal. Then if it is necessary, then only irrigate the water. Maybe that can be integrated along with the weather model. If weather model says that in 2 days time there will be heavy rain, oh, in that case, I don't need to irrigate, right? So the system can manage smart agriculture. So healthcare, city, then this driverless cars, smart cars. So sensing. So these are applications that enable IoT. Then obviously they also need to be supported through appropriate computing paradigm. So let's take a look at this appropriate computing paradigm. The first generation IoT applications. So where primarily cloud centric. You can see here. So the data that is captured, analyzed, sent to cloud for processing, and then action is taken there. So this model is all right. The problem is the response time, the latency will be very high. With lots of by 2030, this increase 100-fold, 1,000-fold billion subject. Then what happens? If all of them push to cloud, the internet will get clogged. Upward traffic too much. So what do? Perhaps we need to look at processing certain data at the edge of the network itself. So edge computing. At homes, you can have a small Raspberry Pi computer costing something like say 2,000 to 2,000 rupees. So the data that is generated locally is just processed here only. Some data can be integrated with the cloud. So this is some data can be integrated with the from here either edge or integrated with the cloud. So you can add this also. So this is what we call, this is edge computing. So this is like a fog computing. Anyway, people are using these terms interchangeably. So bringing cloud-like thoughts towards edge of the network in lightweight manner. Okay, and it has to be lightweight. So how is that we build lightweight? You need to build a lightweight software. So that brings to one of our new software called Fog Bus. Is a framework, lightweight framework for edge and fog computing. It is embedded with blockchain. So we implemented concept of blockchain so that we can create a trustable computing network, and the results that come are trustable. So here is like a device like oximeter, any healthcare device, data capture, send it to say a smartphone where the app is running. From there you send it to a broker. The system can send the computations to different network across edge. Then or it can also use the public cloud. This is conceptually. Okay, of course, inside there are various web protocol or web service protocol integrating them. So this can be put in practice for different applications. One of them is healthcare. So in case of healthcare, you see there are many applications. So usual, the most easiest one or obvious one is remote health monitoring. So during COVID-19, if someone has a symptom, during peak time, the hospitals were discouraging patients to come to the hospital because there is no solution. What is the use of going there? So rather be at a home and see how you're going, unless it's emergency. One can just see by monitoring the various data using the sensors, pressure data, oxygen saturation level, glucose, ECG, blood pressure. These different data can be analyzed and create an interesting application. Or it can be health system management, depending upon type of persons. So we actually created one such application. So this is the device that we procured, available in the market, oximeter. You can connect to hand, finger. Actually, very simple. Then here's the app, HealthKeeper app. HealthKeeper app, data collected. Then from there is sent to cloud, and then this is the visualizer. So after processing on the edge or cloud, it is able to classify disease severity. It can be mild, it can be normal, mild, or an emergency. If it's emergency, take the hospital, otherwise don't worry. So you can see these all can be done very simple. And that means we need to have apps running either the edge or in the cloud environment. We have shown this also demo. You can see here this is connected to the finger, right? The oximeter. So the oximeter, then data goes to the mobile phones, and from there processing is done either in the local. So these are our oximeter. These are our experimental Raspberry Pi. Of course, when you buy it will come like a matchbox, small matchbox size computer, Raspberry Pi. So there can be just fixed anywhere in home, just like just like a switch. So can be used. So this is something we put together: oximeter, iPhone, gateway, Aneka, and Raspberry Pi. So able to demonstrate this concept. So this FogBus is an open source software, by the way. You can download yourself. So the first version was created using Java. Here the second version that is created using Python. So where we are able to support what we call this container-based approach to service hosting. So applications can be devices, varieties of devices. You can see here the different type of devices part of being enabled. Okay, so that is all practical. So if you want to create some new idea, new resource, new technique, doing on practical can be quite a lot of effort. If you are doing a PhD or a research, so it can be quite a bit of effort. So to enable such policy-based research, so we also developed this iFoxim for modeling and simulation. As I said, we have similar toolkit for cloud computing called CloudSim. CloudSim, the latest version is called 6G, 6th edition of CloudSim. So that CloudSim is also used by many companies, such as, for example, Ericsson. Ericsson has used in modeling, mobile services data center. So like that, IBM has used, HP. Then many universities throughout the world. So it looks like you can't write a cloud computing research paper without using CloudSim. So that was so popular. You can go and see as open source software. Many users are using in India, throughout India. There are many training courses people are doing using that CloudSim. So this iFoxim is for edge and IoT. So you can model the data generation pattern of this IoT. Then of course here you can come out with different policies for resource management and scheduling. So this kind of large-scale evaluation is not possible in real world. You can do it in simulation. This is a simulator. This is also open source available, and we just released the new version of this software. The same software plus new capabilities such as mobility. So these days people want to create mobile smart transport environment simulation, or of course have microservices. This is the new software engineering concept. These are made available recently through iFoxim too. So the reason I'm introducing is so there might be number of researchers here, students, PhD students who might take this approach of modeling and simulation. So this technology can be used. So here is my final with this edge. COVID been drone based. So this word drone was also mentioned by our chairman during the introduction. So this so drones have many applications. So one of them is during this lockdown, hard lockdown, when it was happening in Noida. So we work with one company, Robotics Society in Delhi. So these people have got drones. So these are drones, different drones. These are drone. So these drones. So people were staying in this multi-story building in place like Noida, and then multi-story. Then this drone is fitted with thermal camera. It is able to go around the building. the residents of that apartments were asked to come to the balcony. So when it is going around, it is able to measure the body temperature. So if someone is experiencing symptom, the temperature symptom, something like COVID, so you can detect it and then maybe isolate. So this is the drone-based network system for combating COVID-19 pandemic. So this was something actually we put together idea and the demo a year ago, and then already paper is published. You can learn more about it, how the edge and cloud IoT integrated. So here, what is the IoT? That the camera, thermal camera, along with the drone, able to move around and process easily. So you can see, you can also put together interesting application. So now I'm coming to the final, which is what if I add a quantum to cloud? We talk about primarily talking about cloud-like services, but we are adding quantum processor to it. So you know GPU, GPU graphic processing units, then TPU, they were built for especially a workload like this. Then as FPGA, these are application-specific processors. So like that, quantum also now getting popular, and those services are available through cloud. So therefore, I thought I will introduce you briefly what we have done by extending our cloud expertise towards quantum. So this is what we call multi-cloud and quantum computing integration. So this is the paper that we put together. It's available for all of you to access. You type this title, you can access it. And the same QFAS software will be released also. So what is the architecture like? Simple concept. So when you say cloud environment, you'll obviously have classical cloud services, and that also will have some quantum processor also, correct? Like IBM Quantum or Amazon Bracket, like different companies are creating these. And each of these cloud service provider, IBM, Amazon, Google, Dell, and Microsoft also, all of these people are providing quantum capability via their cloud environment. And you also want to harness this across multiple, not only in one quantum cloud service, but also across multiple too. So this QFAS allows you to do that. So you build that model, a compose application using our dashboard. So then inside our architecture of QFAS, so it has got classic layer, quantum cloud layer, then this application deployment layer. So depending upon the application, the capability available, accordingly the components application deployed. Then of course the things have to be monitored, how everything is progressing, the monitoring layer also is there. So this way we can simplify and automate the process of software creation. See, the cost of software engineering need to be reduced, software engineering cost. So having such technology will help you to create rapidly. Then, so this way you can do it for multiple quantum SDKs without worrying about vendor lock-in. You don't have to stick to IBM. You can build in such a way that you can go wherever you like seamlessly. When I go deeper, what is the flow like? The same technology, a deeper flow like, a user request. So you compose using dashboard, then goes to service API. Then here are the different functions. There's a quantum function, classical function, and hybrid function. Accordingly, we can deploy. Your application composes the microservices. You might have a multiple function of the same thing. Depending upon availability of hardware, we pick up the right one. If it's the GPU version, we pick up. Of course, by default is a classical CPU, Intel microprocessor or whichever microprocessor. Otherwise, if you've got a code for it, we deploy that seamless manner. So this way, application developer don't need to worry about low-level details of the infrastructure. They just build the application, the rest is taken care. Okay. So more details on this environment and all, we can show you in the paper is given. The software will be made available for download soon, along with some demos on how it can be explored. Okay. So let me move towards conclusion and then briefly discussing future direction. To conclude, so this concept of computing as utility, so as I said in the beginning, water is a utility, electricity as a utility. So we are already having those. This computing has become a fifth utility. So this was the vision paper I put together in 2008. So very popularly referred by everyone, and of course now other concepts have become real. It took in a computing domain within 5 to 10 years from vision or concept to the reality happens. So which is a good thing. rapidly progressing. So cloud is the one which turned this vision into reality. So no more theory. So many exciting applications are all in cloud. We are using day-to-day basis, which I've discussed, and then many more newer ones I also discussed. Then this Aneka is one of the rapidly emerging solution platform that can be used to build applications rapidly, rapid software engineering. So this way we can minimize the cost and time of software application creation, and also the deployment cost, the solution delivery cost. So we discussed briefly engineering application, healthcare, but there are many applications such as smart cities, gaming, business intelligence, AI. There are so many applications can be built. So I have just touched on few. So as we discussed, move towards IoT. The first generation IoT were mostly cloud centric. The new generation IoTs are combination of edge and fog. As a result, you can support low latency real time IoT applications. Then that way we can reduce also load of the internet. Then we talked about this serverless function as a service framework for quantum computing. So that integrate multi-cloud also quantum. Okay. So what about the future? Are there anything to do? So there are many open challenges. If you want to create some interesting project, so from that perspective, I put together this manifesto. 2 years ago, this manifesto for future generation cloud computing. Manifesto, you all heard about this term, especially during election time. Every party release a manifesto. Here is our manifesto. In India also, party BJP manifesto. They say here is our manifesto for next 5 years. This all we promise you to do it. Like that, similarly here is the manifesto. This manifesto is put together by experts from involving experts from IBM, from HP Lab, from different universities in around the world. Even I also involved a colleague from IS Indian Institute of Science and myself here in Melbourne University. We put together so that identified, they looked into state of the art, identify what are the weaknesses in cloud, what are the new trends, and what are the challenges, and how do we honor that opportunity and directions. So we put together these directions for 2030. So many open challenges are discussed in case if you want to take up a leadership to work on it. So for example, so in case of this, one of the challenges, managing resources efficiently, creating a sustainable computing environment. I mentioned that cloud data centers are consuming energy more than entire India. So maybe you want to reduce that energy consumption by 50%, big achievement. So that requires you to go for next level of next model. The current approach to cloud computing is very much like a discrete resource management. We need to move from discrete management of different resources and the capabilities towards integrated management, holistic. So more details are discussed in our paper. So you can see where you need to consider, the nature of application. One, is it compute intensive, is it data intensive, and the type of energy source, is it brown energy or green energy? Then different user requirements, quality of service requirement. So all these things need to be taken into consideration, and in a holistic manner you need to manage. So this is require another new dimensions in research, very key area. In fact, yesterday we had a conference in San Francisco. So experts from different companies and researchers, we come together, discuss on sustainability. So lots of challenges are identified in that one. Then we also discussed that in our 360 degree view of cloud computing from energy perspective. There is one big article recently published. You can read that. Okay, so now coming to learning. So those who are new to area, obviously, universities are including courses. Like those who are in US, this is Mastering Cloud Computing book for US market. So this is costing $100. So this can be too expensive for us, especially our currency exchange rate is changing too much, so not affordable to everyone. So we have Indian edition, don't worry, correct? So same book, Mastering Cloud Computing, published by McGraw-Hill in India. So this is probably equivalent of $4. Okay, $4 might be around 400-500 rupees. You can buy it from any various bookshops in India. Yeah, so there's book. Then we also have the same book for Chinese also. Chinese won't understand English, so we need to have a Chinese version of the same thing. Some professors from China have converted the book to Chinese, so this is probably available for them at $3. People often ask me why $3, why not 4? The reason is the translated version of the Chinese text. So our Indian edition book is 500 pages. The same thing when they translate to Chinese character, that became only 300 pages because very compact. You see here, just my name in English it look like Rajkumar Boya, so one long one line. The same Chinese only one this much. They put two several things in one box. Okay, so it looked like a Tamil or maybe Malayali.
The reference books names are given is enough, sir, Professor. That costing may not be area of concern for the students.
Yes, yeah. So this is yeah. So there, of course, the English. I mean, the programs are in English, so therefore that has become little big. Otherwise, it would have become 250 only. Yeah. So actually, this book has got 4 chapters. Okay, the 4 chapters in which talks about Aneka programming using thread model programming, task model programming, very detailed along with the exercise and so on. So that way we can learn programming. So IoT, here is the IoT book as well. Then this is Fargate computing book as well. So okay, so with this, let me stop here, and I'd like to thank all of you for hearing patiently. So here are my contacts. This is my those who want to collaborate or interact from research and education. You can use my Melbourne University email ID, and say those who want to maybe do entrepreneurship or set up cloud lab, you can send email to raj@manjasab.com. Okay, so thank you again for hearing patiently. So we will now open up for question answer discussion. I think we have got sufficient time, right?
Yes, yeah, we have.
Yes.
So thank you so much, Dr. Rajkumar Bhuya. It has been very engrossing, absorbing, and I think we can go the whole day also, but due to paucity of time, we will try to take questions and answers as of now. So people can raise the hands, and then I can read out the names so that you can ask the questions, and we will unmute you. So we have here Angel Bessie. Manali, if you can unmute her or Angel Bessie. Hello, Angel Bessie is there? If he's not there, then we can have Dr. Brahampal Singh.
Hello, am I audible, sir?
Yes, you are.
Okay. Good morning to all of you. Sir, I want to ask that this internship will be in online mode, offline mode or online mode that you have described that you can contact for internship.
Oh, so there is for internship. I didn't mention about internship. For research education, if they want to study at Melbourne University, for example, so they can contact me. I can clarify. So that is all online mode. No, online mode. Sorry, online mode are there. But nowadays we are a campus-based university, so students register here.
So some charges are there. If you can tell me.
So no, let me make it clear. University of Melbourne is more a campus-based university.
Okay.
So when students, for example, join us here for PhD or for a master's or coursework, they can apply to University of Melbourne. But if those who are doing research, for example, say some of you are doing research and want to interact with me, researchers, so you can send me an email to that Melbourne University email, rboy@unimelb.edu.au. That's what I mean. Or if you want to set up a cloud lab in your college,
Yes.
so you email me. So we can help. Yeah.
Right, sir. Thank you. Thank you.
So we have various resource person experts in India who can come and install and help.
Thank you. Thank you, sir.
And there was a message saying that the person saying that unable to download Anika software. I actually just no, stop it here. I say so I just clicked and then downloaded. Here is the download. Click. So here you put direct download. You click here, so it will see MSI you can download. Okay, so mothership.com. Question was there. Download, click. So here you can go here and direct download. Okay, free version Aneka 5.0. I hope that answers. I already put the link, direct link, in case if somebody wanted to.
So for paucity of time, we'll just take one more question and then we'll close this thing. So that Dr. A.V. Senthil Kumar. Dr. A.V. So if Dr. A.V. is not available,
Are you there?
Senthil Kumar.
So once again,
So we can, because of the paucity of time, sir has also been engaged more than 1 hour. So we can close the John. We can close.
Yeah. So finally, I would like to thank all of you, the participants and people who are there watching on YouTube. Before I forget, let me put this also, that the recording can be watched on AICT YouTube live. So anytime you can go there. If you have not got Dr. Bhuya's the email ID, you can get there also. So first of all, would like to thank our Honorable Chairman, Dr. Professor Anil Surasbuddhe, and thank again Dr. Amit Datta. And special thanks to Dr. Rajkumar Bhuya, who has been gracious enough to talk to us from his taking time out from his busy schedule. And it has been an enlightening talk. As I said, it has been engrossing and absorbing. We can go the whole day. And we will look forward to many more sessions like this, Dr. Bhuya sir. And thank you so much again. We'll close here for the session. Thank you again. Thank you.
Thanks again for having me. Thank you.
Thank you.